Hello to Wednesday. Kahoot period. I think today is the 10th day. Yeah, today is the 10th day. So today is also the... Oh, hello. Hi, Jiaying. Okay, let's try the duo. Last time we didn't work. Yes. Duo. Last time she tried to reverse psychology the thing. I'm like, hey, that's really cool. How do I do her? I just copy the name. Okay, 10. Set. Please don't Hello, hey Nicole, hey JYY. Okay, accept. Jiang, accept. Fight. Hey, Ken, I think hopefully Ken. Hey, Ken is fighting already. Oh my god, you crit. Oh, that's painful. Oh no. Oh no, I think I'm gonna lose. Ho. Crit. I need a crit. Oh no, it's over. Shing. Shing. Oh. Oh no, I died. Cool. Hello, hi everyone. Okay, so today's gonna be acid, base, and salts. Monday time it will be Oh really? Okay, maybe I need to go buy weapon. But I did one against Slipfish with the ball. I don't know what weapon is that. Is a ball? You have a blue ball? What's that? Yeah, I did one against that. It's like, But anyways. Hey Bob. Hello. Magic stuff. Yeah, maybe it's a magic stuff. So today compared to Monday will be more challenging. Monday is more of introductory to acid, base, and alkali. And today the difficulty got tuned up. So there are more, I would say, more details to process in most questions, more thinky. So that's that. So yeah, same thing. We will start sharp at about 9:06, 9:07 for everyone. Because usually I think is it chicken teriyaki or teriyaki chicken and lala? Yeah, they will like spend some time. But we're not gonna like give them too much time. You then in their time you waste like other people's time, right? So yeah, I was a bit disappointed that Buzz Lightyear movie is like I cannot watch it. It's like it's not widely distributed. So that's that. And Elvis Presley movie is coming out, I guess. So maybe I'm gonna try to watch that. So that's that. It's the last week of the holiday. Any interesting things to do? I heard about there's something called you don't like the Lightyear guy? Are you more of a Woody guy? You like Woody better? Oh my god, you him. I know, like, so sad. You like Woody better? Or you like I think that's a female version of Woody. I don't know what is it called. Or like Toy Story because it's like creepy. Like you might wonder whether your toys like come alive at night. It's a bit scary though. So yeah, that's pretty much it. I mean, and then there's the Minions movie coming out soon too, I guess. So that's that. I do I do know that there's this interesting thing in Sentosa called Hydro Dash. Sounds cool. Like it's like obstacle course but floating on water or something. Okay, chicken teriyaki. the chicken. Yes, you have a very funky spelling of chicken today. Okay, 9:06. We're gonna start in one. We're gonna banana. We're gonna start in 1 minute time. 9:07. With or without Lala, I guess. Yeah. Oh, speaking of the devil, Lala's here. Okay. Hey, Lala. Good. Just on time. We always start at around 9:07, right? So that's that. Yeah, well, I heard the Minions movie is like supposed to came out way earlier, but got dragged by the pandemic. Then now it came out, the Rise of Gru or something. Yeah. Okay, 9:07 is here. Let's start, I guess. Okay, anyone who is later, feel free to join. The room code is left open. It's posted on Discord. So yes. Okay. Yep. The Rise of Gru. Fried rice. Moderator. Never mind. Welcome to Wednesday, the 10th day of June holidays. Kahoot. Acids, bases, alkali. Let's go. So let's start with something relatively straightforward. This is something quite straightforward about whenever they use things like methylbenzene, toluene, all the weird words, it always means that there is, on purpose, saying acid with no water. That's what they're trying to hint towards. Good. In this case, right, it'll be hydrogen chloride does not produce hydrogen ions. Without water, acid does not produce ions. Without ions, it cannot be acidic. So the pH remains neutral. Answer will be red. In this case, the key thing is pungent gas that turns red litmus paper blue. So if you know the gas, this should be quite a straightforward question. Very good. Ammonium chloride is the answer. So no explanation needed. Main thing is basically, as long as you have a alkaline solution, in this case alkali or base, reacts with ammonium, you get ammonia gas. Nice. Okay, question 3. This is testing what we did not test last week, which is on ionic equations. Okay, you might need to do on paper, consider the product, solid liquid gas copy down, only test apart the aqueous, lastly cancel similar ions left and right. Or you can do it another way where you consider, yes, okay, in this case, right, how do we do this? There's the proper way of doing this, and then there's a shortcut way of doing this. Okay, so let's explore this in total. So what happened is, in this case, we have ammonium nitrate reacts with potassium hydroxide. So what you get is ammonium. Oh no, it's not ammonium one. It will be potassium nitrate plus water plus ammonia gas, right? Then what happened is, once you do that, and 4 5 3 4 5, so it's all auto balance. So what happened is, this is aqueous, this is aqueous, this is aqueous, this is a liquid, this is a gas. So automatically, if you copy down, you know that the final formula will have H2O and NH3. So if you do elimination, you will realize that answer can either be yellow, red or yellow. It cannot be any other thing else, because it has NH3 and NH3 and H2O. But in this case, most likely the answer is going to be A, because NO2 is not a product. So if you can exploit this bug, this shortcut, you'll know the answer is red already. But other than that, you can consider this is aqueous, this is aqueous, nitrate can cancel, K and K can cancel. Then you only left NH4 plus OH. So this is like a shortcut version of doing multiple choice, of showing how you can actually get the ionic equation immediately by figuring out liquid, gas, copy down, and then what's in front as a whole. Answer in this case will be red. So of course, if you're not sure about the proper way of doing this, we can just bring it up to me, and I will just personally teach you the proper way, and then revise the shortcut as well. Okay, let's go. Question 4. There is a certain challenge to this question, so yes. Yeah, I know, right? I don't want holidays to end too. How nice is everyone gets to sleep nice, be very alert and feels good in doing learning, freedom and to do anything at any time they want, rather than wake up super early and get stuck in school. Oh, Slipfish, Hydro Dash. Maybe you should go Hydro Dash, huh? Yes. Okay, so question 4 as a whole talks about the different color things, right? Then if the pH is 2, it will be acidic oxide, so you get sulfur. Sulfur is a non-metal. The key thing is that to know non-metal is acidic, metal is basic. So then your answer will narrow down to CD, because if T is acidic, V with pH 10 is alkaline, in other words basic, the front will be acidic, therefore sulfur. The back V will be metal, which is in this case calcium. The only challenging part for this question lies in most copper stuff that you learn is going to be blue. In fact, copper oxide is the only weird color, which is black. Okay, when I say weird color, means that it's different from blue and green. Copper oxide is a unique color. In this case, answer will be C, because aluminium oxide is white. Okay, aluminium oxide is white, so that's why answer is C. Answer is not D, because copper itself is blue. Yes. Okay, moving forward. Which compound will remove acidic substance in the soil but will not react with ammonium fertilizer? Will not react with ammonium fertilizer but reacts with acid. Yeah, slipfish, hydro dash. I don't know whether we will make it. I don't know. Is there a weight limit on the hydro dash? It's like jump, jump, jump. There's a no capsize. But it's interesting though. We should go and try. So this question mainly talks about whether what reacts with acid, but not ammonium. So technically it's yes. In other words, you're looking for something as, because calcium hydroxide is an alkali, calcium oxide is a base. Both alkali and base reacts with ammonia. So blue and green is out. We are looking for will not react. So it has to react with acid, but not an alkali or base. So automatically answer will be a carbonate. A carbonate reacts with acid, but will not react with ammonium fertilizer to give ammonia gas. So blue and green is automatically out. Yellow just is a neutral salt. Nitrate salt is a neutral salt, so does not react with acid, does not react with alkali or base. So answer will be red. As long as you are smaller than one whale. Yes, slipfish. I think we should try. Which of the following statement is true for a weak alkali? Oh, weak alkali. Oh, this one, it's looks simple, but I think there's a hidden. I think the answer is a bit hidden, but let's see how it goes. Be careful, yeah. All the question today is hand selected to some of them to look simple, but there's tricks built into it to make small mistakes. Yes, just like this one, you see. In the end, right, if the thing is a weak alkali will definitely not be pH 7. That's neutral. Weak alkali will react just like any other alkali to form salt and water, not just salt only. It will be yellow because it will react with lead oxide. Lead oxide is an amphoteric oxide. So that's a hidden oxide questions of amphoteric. Amphoteric can react with acid and base. And green, it releases carbon dioxide. Wait a minute. When it comes to ammonium carbonate, acid with carbonate forms carbon dioxide. If it add alkali targets the ammonium part to produce ammonia. So be careful of this problem, this ammonium carbonate. If it's acid, it reacts with the carbonate. If it's alkali, it reacts with the ammonium. One is in front, one is at the back. And the gas that gives up is very different. Okay, so weak alkali is going to be ammonium and ammonia gas. Acid is going to be reacts with carbonate to give carbon dioxide. Answer will be yellow. Okay, question 7. Which of the following methods could be used to obtain a pure sample of carbon monoxide from mixture of carbon monoxide and carbon dioxide? Okay. Okay, in this case, right? Okay, in this case, if we look at the question, you wanted something to okay, maybe let's use the digital whiteboard or blackboard or okay. So you have carbon monoxide and you have carbon dioxide. Carbon dioxide, it's the words are really tiny. Yeah, I know. Hopefully they can like zoom in on their phones, hopefully, but I know it's really 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 small. I'll take note of that. Maybe not type so many words on it, but yeah. So what happened is carbon dioxide is like an acidic oxide. whereas carbon monoxide with the no cold water is a neutral oxide. So your best bet, neutral, TR, neutral. Okay, so your best bet is to find way, in this case most likely put in an alkali. The alkali will react away and absorb all the carbon dioxide, and then we will have no reaction with the carbon monoxide, so leaving carbon monoxide behind. So in this case, if you were to look at this, blue will be passing the mixture through potassium hydroxide, which is an alkali. The alkali will make sure all the acidic oxides, all the carbon dioxide go bye-bye, so then you can collect the carbon monoxide, which is why you want the carbon monoxide. Okay, so answer would be blue. Of course, of my calculation or my explanation, if something just go like, huh? Then you can totally just type in chat and say, I don't understand, then I'll just re-explain it or something, okay? Or find a better way to explain it, because sometimes, you know, explanation from a teacher may not be the most clear, because, you know, it's different perspective between teachers and students. So I try to be in your shoes so that I can explain better. So yes. Okay, element P reacts with oxygen, forms an oxide. When dissolved in water, the solution turns blue litmus paper red. So it's an oxidized, it's an acidic gas? I guess it's an acidic gas. Oh, look at her go. Clicking answers, gaining points, playing jackpot. Pretty cool. Okay, in this case, right, the answer will be yellow. So what happened is that if there is blue turning red, that means it's acidic gas. Acidic oxides. If it's acidic oxides, it should be non-metal. If it's non-metal, it should be gaining electron to form ions. So answer will be yellow. Okay, so that's that. Red is not possible because shiny appearance is metal, delocalized electrons is metal, malleable is metal. So answer will be yellow. Okay, question 9. This is a very typical question that comes up normally in paper 2 that talks about a farmer tries to put fertilizer, but at the same time also try to neutralize the soil with normally with something called lime, like slick lime, which is calcium hydroxide. And then why is it a bad thing? Then the outcome will be you dust something to the fertilizer and then your whole farm will smell like a toilet. It smells funky. So yes. So in the end, answer is calcium hydroxide will react with ammonium nitrate to release ammonia gas. So alkali plus is the same thing, where calcium hydroxide and alkali will react with ammonium nitrate to form ammonia gas, making the fertilizer useless. But fertilizer needs to supply nitrogen. Now all the nitrogen become ammonia gas and left the soil. So not only that, the soil become useless in terms of fertilizer, and now the whole farm smells bad, I guess. So yes. Okay, moving forward. So we're looking for amphoteric. This one is different. That's all I can say. Of course, all the questions today, difficulty is increased. So yes. So you have to think about the logic of, if something is basic, it will react with acid. If something is acidic, it will react with alkaline. So what's a situation where it's amphoteric? What's so special about it in terms of its reaction? Okay, good. In this case, right, the main thing will be if something is a amphoteric, it will be a metal. In this case, you'll be considered as a metal oxide that somehow reacts with alkali. Okay, so in blue, you get potassium hydroxide that somehow reacts with alkali. Yeah, because what happened is normally metal oxide should only react with acid. It shouldn't react with alkali. If it can react with acid and alkali, we call it amphoteric. So KOH with IN2O3, it's the exception. So therefore, it's amphoteric. So yeah. Okay, good. Okay, a student was given 2 samples of salts. Which following test were able to distinguish the salt? So tell the difference. So this is more of a paper 2 scenario where they tell you how to tell the difference through different reactions. Should be quite straightforward if yes, in this case, right, you'll be heating it with potassium hydroxide because one of them is ammonium. Ammonium will react with alkali to form ammonia gas. So in this case, if you're heating with acid, nope, it doesn't react with both. Potassium chloride is a neutral salt, ammonium sulfate is a neutral salt. There's no carbonate, no metal, no base, no alkali. So green, heating each chemical with acidified potassium dichromate. Potassium dichromate is an oxidizing agent. So it does not, it's not within the syllabus like what we test for now, but it's not the answer. The main thing will be testing a student's understanding of ammonium can be tested with alkali, which is yellow. Okay, moving on. This is a callback, something similar to acid, bases, salt, this chapter, and it's a callback to last week's periodic table. Okay, in this case, right on the left side will be metal, right on the, if it's a periodic table, okay, let's talk about periodic table. If it's a periodic table, then you have the, oh my god, I drew a bit too big, staircase. Oh, this part is going to be metal. Then, oh, this part is going to be non-metal. General idea. And then there will be small little elements, normally zinc, aluminium, lead sandwich in between. So if you were to arrange it this way, the one X will be basic oxide, Y will be acidic oxide, Z will be amphoteric. So if you arrange it, it will be X being basic oxide, then amphoteric Z sandwich in the middle. So X, Z, Y. Answer will be blue. Okay, question 13. This one is not difficult, but there's a multi-step question. They have multiple concepts to process. There's something to do with thermal decomposition as well. Okay, in this case, right, this question has multiple parts to consider. That's why it was considered as a challenging question. Okay, so let's look at this. So what happened is you have to understand thermal decomposition, which is previously definitely need to be mentioned in Sec 2 for the reactions, right? So in this case, right, there is, let's call this X and Y. In X crucible, so magnesium carbonate in X, magnesium carbonate is heated strongly, so you will thermal decompose. Okay, let's get rid of Y first. You thermal decompose to form magnesium oxide plus carbon dioxide. So you can understand for Y, after being heated, it becomes magnesium oxide already. Whereas for Y, Y was not heated, so Y will just outright contain magnesium carbonate because nothing was done to it. So then in this case, if this one reacts with acid, this one also reacts with acid, the first one definitely will form carbon dioxide, therefore effervescence. And since this one has turned into magnesium oxide, it will be base. If it's a bases, right? No gases will form. You just form salt and water. So therefore, no effervescence will be observed. Answer will be C. Okay, answer will be C. That's why it's yellow. This is, please take note to answer this, right? Is must be true. That means that whatever given to you must not have any exception at all. So in itself, it's challenging. It's a tricky question, yeah. So, yeah. Clipfish, what is base based on? What did I say is base? Why come I don't know? Based on a true story. No, what story is that? Is it a good story? Okay, so in this case, right? Okay, so in this case, right, the question, as I said, is also considered tricky. Some may look like it's correct, but actually there are like exceptions. Okay, let's look at this. In this case, right, if you look at the thing, okay. Number one, it says must be true. All acids completely dissociates? No, right? Only strong acid dissociates completely. There are still weak acid that dissociates partially, so number one cannot be. Is all their pH value 7? Definitely not. 7 is going to be neutral, right? So that's that. They react with all metals to produce hydrogen. That's not true. Their exception is except copper, silver, gold. So 3 is also not correct. Monobasic are weaker than dibasic. In this case, oh wait a minute, their pH value is less than 7. Oh my god, I didn't see that. So number 2 is correct. Number 2 is correct. Monobasic are weaker than dibasic. That's not entirely true. I can have a strong monobasic and a weak dibasic. Then monobasic will be stronger. So mono and dibasic do not directly cause difference in concentration and weak and strong. In other words, if strong versus strong or weak versus weak, then only it matters. So if you take a monobasic strong versus a dibasic weak, a monobasic strong will still be stronger, even though it's just mono compared to di. Okay, so mono and dibasic may not be confirmed true all the time. Answer in this case will be blue. They must be definitely less than 7. So 2 is the answer, blue. Okay, a sample containing powdered mixture of metal, iron oxide and zinc oxide. Then which of the following should use to remove zinc oxide? Is something similar to what we did earlier on. Good. In general, oh no, no good. What? Why so many people choose sulfuric acid? They want to separate iron and zinc oxide. Iron is a metal. Metal will react with acid, right? And zinc oxide is a base. It will react with acid as well. So in this case, we definitely cannot use acids. So red and yellow is both out because red is sulfuric acid, yellow is weak acid. So in this case, answer should be alkali. Why is it an alkali? Because zinc oxide is amphoteric. Amphoteric reacts with alkali, but metal do not react with alkali. So zinc oxide reacts with alkali, gets removed. Then we filter away to collect the iron powder. Answer will be blue. So both acids are not possible. Alkali will be the answer. And distilled water don't do anything because zinc oxide is not soluble. All oxides are insoluble except for SPA and group 1. So yes. Okay. Question 16. Which of the methods are suitable to test the strength of acid and alkali? This is also a challenging one. Okay, in this case, you have to think about whether strong and weak acid has different concentration of ions, how it will affect the different things you use to measure the difference in ions. But, oh, no. But how much money do you have? In this case, right, answer will be... Okay, answer can be contentious between titration, whether titration is or is not, okay? In general, measuring conductivity measures the electric conductivity, measures the concentration of ions. When it comes to the pH meter, it measures the amount of pH. So 2, 3 has no argument. It must be correct. Titration, right, it becomes this weird thing. Some teachers in school will say no, titration only finds out the amount. Okay, they say they only finds out the amount of the amount of the how much alkali or how much acid that's required to neutralize, right? But in this case, answer will be all of the above. Reason is because, okay, let's say you do titration. And let's say you do titration, you definitely draw a titration curve, right? So you draw a titration curve. The starting number here, let's say it says 2. 2 tells us that it's going to be a strong acid. If the starting curve is like that, Starting here is 6. It tells us this is a weak acid. So your starting point and of course your ending point, if it ends here, let's say it's 8, versus it ends here, which is like 13. It tells us whether it's strong or weak alkali. So the start point, end point of the titration curve tells us whether that the acid or alkali used is strong or weak. Whereas if the question is asked in such a way that does titration finds out the concentration, like the actual concentration, answer is no. We will never find out the actual concentration difference between strong and weak, but we can know it's strong and weak based on the end point, where it's first added and when the whole titration curve ends. So answer would be, in this case, 1, 2, 3, all of the above. So yes, this is, as I said, it's super tricky stuff. Nudge, nudge, hint, hint. We will compile things like this and put it in the final. You never know. In the final Friday giveaway round. So yes. Which graph shows that in pH excess magnesium oxide? Okay, I mean, at least they let you win 10 again. You won 10 from slots now. So this one has something to do with last week's question. Something to do with it. Something about soluble, insoluble, alkali based thing. Okay, in this case, right, the answer will be red. Why? Magnesium oxide is insoluble. If it's an insoluble base, no matter how much we add, the amount will stay stuck at pH 7. Adding more will never mix it, because it's not soluble, it will not form extra OH minus or so-called hydroxide ions. So therefore, its maximum pH will never be more than 7. Unless you are using something like a soluble oxide or soluble hydroxide, such as potassium hydroxide, then the more you add, it goes all the way up to 13, 14. So answer for this will be red. Okay, definitely not blue, because blue is decreasing. That will be adding acid to alkali, and definitely not yellow, because yellow hints that it's an alkali, but magnesium oxide is insoluble. So be careful of whether something is soluble or not. So it will tell you how the curve will behave. Okay, question 18. Same thing. This is on purpose arranged this way so that whatever I explained earlier on applies to here. It's exactly same thing. You see that the graph is 7. 7 means that it's an insoluble oxide. Make sure that whatever is added to it is insoluble oxide. Look at the starting point is 2. 2 means that it's a strong acid, you know. Yeah, same thing. So today is all the practice round for all these little tricks that I observed over the years that came out in actual prelim paper and then like murder students' motivation. Like no. So yeah, so make all the mistakes here so you don't make it in school, you see? So yes. Very good. Okay. Everyone got it. Okay. Yes. So in general, the base will be magnesium oxide because it's insoluble. The strong acid will be nitric acid. So ethanol acid definitely goes up. Answer will be blue. Okay, cool. Okay, there are damn universal indicator paper. So this one, it came out very often in paper 1. Yes, paper 1 on what when L and M separates, then their gases form. It says that the universal indicator turns blue. Then you have to, oh, in this case, all I can say is ammonia is formed. And the rest is up to you. Hopefully, please. Oh, okay. In this case, right, it will be ammonium plus sodium hydroxide. Because the gas we know form is basically ammonia. Ammonia forms when ammonium salts plus alkali. So answer is yellow. Alkali, which is sodium hydroxide, plus ammonium nitrate, which is an ammonium salts. Okay. Let's go. Last question for the day. Solid X forms a residue. Anyway, for those that might be new to do this round, right? Monday, Wednesdays are practice rounds for the chapters. Friday is the one. Friday round. Anyone who gets 50% and up means more than 10 questions out of 20. Your name will be put into a lucky draw, and lucky draw will whoever gets a lucky draw will happen on Monday, and whoever gets their name drawn, a prizes will be given. So yes. Okay. Wow. Okay, so this is a very equally split. I think I should explain. So it says when the residue yeah, forms a residue and gas when heated. So what happened is when it says something can form a residue and gas, it's something to do with thermal decomposition. Okay, so in this case, okay, look at this. So in this case, solid X tries to be heated, it forms a residue and a gas. High chance this is going to carbon dioxide, and this is going to be something carbonate. Residue is going to be something oxide. So the gas bubbled through is lime water. Then we just confirm that this is carbon dioxide because lime water. White precipitate form. So something carbonate is white. I don't know what it is. The residue is able to react with dilute hydrochloric acid and sodium hydroxide. So most likely this is going to be zinc, aluminium, or lead carbonate. So by that explanation, if you look here, answer will be zinc carbonate because it has to fulfill a carbonate with amphoteric, means zinc, aluminium, or lead. Answer will be green. And this is day 10 of the Kahoot session. Okay, so that's that. So all the more challenging questions will be analyzed for the 2 days, and we also will add in more tricky questions for the Friday draw. Do your best, as long as anyone who gets 10 and above gets to go for a lucky draw. Yes, and yes, yeah, yes, I promise it will be the value will be worth your effort. And if you're interested in what it is, you can drop me a message about it. So that's that. Work hard, guys. See you guys most likely on Friday. Okay, Friday 9 p.m. It will be also just nice to be the ending of June holidays, I guess. Okay, and after this we will rearrange and then have this more regularly after everyone has like handling the test or whatnot. So we will definitely plan for this. Yep. Okay, thank you so much, everyone. Have a nice day. I see you guys on Friday, and let's end this June holiday with a bang. Okay, see you. Thank you so much for coming. Thank you. Bye bye. Bye bye. Yeah, I want holidays too, man. But it's ending. I know. Bye bye.